The nearest star to Earth is so far away that the human mind struggles to understand the distance. Every night, when we look up at the sky, the stars seem close together. They appear as tiny points of light scattered across the darkness. To our eyes, the universe almost looks compact, as if traveling between stars might simply require a faster rocket. But reality is far different. The closest star beyond our Sun is Proxima Centauri, located approximately 4.24 light-years away. That number may not sound particularly frightening at first. After all, 4 is a small number. Yet hidden inside those 4 light-years is a distance so vast that it changes the way we think about space itself. To understand why, we first need to understand the speed of light. Light is the fastest thing known in the universe. Every second, it travels nearly 300,000 kilometers. At that speed, light could circle Earth more than 7 times in a single second. Now imagine maintaining that incredible speed for an entire year without slowing down even once. The distance covered during that journey becomes 1 light-year. 1 light-year equals approximately 9.46 trillion kilometers. And Proxima Centauri is more than 4 of those light-years away. Suddenly, the nearest star no longer feels close. Instead, it begins to feel almost unreachable. Human civilization evolved on a small rocky planet orbiting an ordinary star. For most of history, we believed the stars were simply lights attached to a giant celestial sphere. Ancient cultures could not imagine the enormous scale hidden behind the night sky. It wasn't until modern astronomy revealed the truth that humanity realized how isolated we really are. The planets in our solar system seem distant to us. Mars appears far away. Jupiter feels unimaginably remote. Neptune exists at the frozen edge of the Sun's domain. Yet compared to the distance separating stars, these worlds are practically neighbors. If the solar system were reduced to the size of a coin, the nearest star would still be kilometers away. The empty space between stars is not a gap. It is an abyss. And despite all our technological achievements, humanity has barely taken its first steps into that abyss. We have sent astronauts to the Moon. We have explored Mars with robotic rovers. We have visited every major planet in the solar system. But reaching another star remains one of the greatest challenges ever faced by our species. Even the fastest spacecraft ever launched by humanity would require tens of thousands of years to make the journey. Long before arrival, every nation on Earth would change. Languages would evolve. Cities would disappear. Entire civilizations could rise and fall. Yet the spacecraft would still be traveling through darkness. And that raises an unsettling question. If the nearest star is this far away, then just how large is the universe around us? The answer is far more shocking than most people realize. The answer is far more shocking than most people realize. To understand just how enormous the universe truly is, we need to start with something familiar. Imagine you are standing on Earth. The planet beneath your feet feels huge. Traveling from one side of the world to the other takes many hours even in the fastest passenger aircraft. Oceans stretch across thousands of kilometers. Entire continents can take days to cross. For most of human history, Earth seemed infinite. Then we discovered it wasn't. As technology improved, distances that once felt impossible gradually became manageable. Ships crossed oceans. Trains connected continents. Aircraft shrank the world even further. Today, we can travel around the entire planet in less than 2 days. But the moment we leave Earth and look outward, everything changes. The Moon is the first reminder that space operates on a completely different scale. Our nearest celestial neighbor is nearly 384,000 kilometers away. That sounds impressive until you remember that astronauts reached it in only a few days during the Apollo missions. The Moon feels distant, yet compared to the rest of the universe, it is practically in our backyard. Next comes the Sun. Light from the Sun takes about 8 minutes to reach Earth. Every sunrise you have ever seen actually happened 8 minutes earlier. The sunlight warming your skin began its journey before you even looked outside. 8 minutes may not sound like much. But remember how fast light travels. If even light needs 8 minutes to cross the distance between Earth and the Sun, that should give us a clue about the incredible scales involved. Then we move outward. Mars, the planet that many scientists hope humans may someday visit, is often tens of millions of kilometers away. Depending on where the planets are in their orbits, communication signals between Earth and Mars can take many minutes to arrive. Imagine sending a message and waiting for the reply, knowing that even at the speed of light, conversation itself becomes slow. And Mars is still close. Jupiter sits much farther away, dominating the solar system with its enormous mass. Beyond Jupiter lies Saturn, surrounded by its magnificent rings. Beyond Saturn are Uranus and Neptune, distant worlds drifting through darkness where sunlight is weak and temperatures plunge to extreme lows. Even these giant planets remain within the Sun's gravitational kingdom. The true edge of the solar system lies much farther away. Scientists believe a vast region called the Oort cloud surrounds our planetary system. This enormous shell of icy objects may extend trillions of kilometers into space. If the planets are cities, the Oort cloud is the wilderness beyond civilization. And even after crossing that unimaginable distance, you still haven't reached another star. Not even close. This is where human intuition completely breaks down. Our brains evolved to understand forests, rivers, mountains, and oceans. We can imagine 1,000 kilometers. We can even imagine traveling around the world. But trillions of kilometers? The human mind struggles. That is why astronomers rarely use kilometers when discussing stars. The numbers become too large to be practical. Instead, they use light years. A unit created specifically because the universe is too big for ordinary measurements. And once we start measuring distances in light years, something remarkable becomes clear. The stars are not crowded together. They are separated by vast oceans of emptiness. If the Sun were reduced to the size of a grain of sand, the nearest star would still be hundreds of kilometers away on the same scale. Most of the universe is not made of planets, stars, or galaxies. Most of it is simply space. Endless, silent, nearly empty space. This realization changes everything. Science fiction often portrays interstellar travel as routine. Characters jump between star systems in minutes or hours. Entire civilizations spread across the galaxy with ease. Reality is far less convenient. The distances are so extreme that even reaching the nearest star presents challenges unlike anything humanity has ever attempted. And yet, despite these obstacles, one human-made object has already traveled farther than any spacecraft in history. It has crossed the realm of the planets. It has entered a region no human being will likely visit for centuries. For nearly 50 years, it has continued moving deeper into the darkness. Its journey is one of the greatest achievements in human history. And the farther it travels, the more it reveals an uncomfortable truth. Space is not merely big. It is far bigger than we ever imagined. Space is not merely big. It is far bigger than we ever imagined. The problem is that words like big, vast, and enormous quickly lose their meaning when discussing the universe. No matter how many times we use them, they fail to capture the true scale of what exists beyond Earth. To understand why, let's perform a simple thought experiment. Imagine shrinking the Earth until it becomes the size of a marble. At this scale, the Moon would be about a meter away. That seems reasonable. Now place the Sun into this model. Surprisingly, the Sun would no longer fit in the same room. It would be located more than 100 meters away and would appear as a giant sphere over 10 meters across. Already, the distances are becoming difficult to visualize. But things become truly absurd when we continue outward. Neptune, the most distant major planet, would be several kilometers away from our marble-sized Earth. The entire solar system would stretch across an entire city. And yet, even this gigantic model fails to prepare us for what comes next. Because the nearest star would not be in the city. It would not even be in the same country. The closest stellar neighbor would be thousands of kilometers away. That single comparison reveals one of the most important facts in astronomy. Stars are incredibly isolated from one another. When we look up at the night sky, thousands of stars appear scattered across the darkness. To our eyes, they seem packed together. But this is an illusion created by distance. A bright star may be dozens of light-years away. Another nearby point of light might actually be hundreds of light-years farther. They only appear close because we are viewing a three-dimensional universe from a single location. Imagine standing in a forest and looking toward distant mountains. Trees separated by hundreds of meters might appear side by side from your perspective. The stars behave in the same way. The night sky is not a flat ceiling. It is a deep cosmic ocean extending in every direction. And within that ocean, the distances become staggering. Consider this. If humanity launched a spacecraft today and somehow managed to maintain a speed of 100,000 kilometers per hour without ever slowing down, the journey to the nearest star would still require thousands of years. Thousands. Not decades. Not centuries. Thousands of years. Entire chapters of human history would pass before arrival. Empires would rise. Nations would disappear. Languages would transform. Generations would come and go. Yet the spacecraft would still be traveling through the darkness between stars. This is one reason why interstellar exploration remains one of the greatest technological challenges humanity has ever faced. The universe is not stopping us with walls or barriers. Instead, it confronts us with distance itself. Distance is the obstacle. Distance is the challenge. Distance is the enemy. Even light, the fastest thing known to exist, requires years to cross the gap between neighboring stars. Think about that for a moment. Every beam of starlight you see tonight began its journey years ago. Some started traveling before smartphones existed. Others began moving through space before you were born. Some visible stars are so distant that their light left before modern civilization even existed. When astronomers observe the universe, they are not simply looking across space. They are looking back through time. A star located 10 light-years away is seen as it existed 10 years ago. A star 100 light-years away appears as it looked a century ago. A galaxy millions of light-years away is viewed millions of years in the past. The farther we look, the deeper into history we see. In a strange way, the universe functions like a giant time machine. Every telescope becomes a window into the past. Every distant object tells a story that began long before its light reached Earth. Yet among all the incredible discoveries made by astronomers, one realization stands above the rest. Our solar system is only a tiny fraction of something much larger. The Sun is not unique. It is one star among hundreds of billions inside our galaxy. And our galaxy itself is only one among countless others scattered throughout the cosmos. Suddenly, the distance to the nearest star begins to look small. Because beyond the neighboring stars lies something even more astonishing. An entire galaxy filled with worlds, suns, and mysteries stretching farther than the human mind can easily comprehend. And once we begin exploring the true size of our galaxy, the scale of the universe becomes even more unbelievable. And once we begin exploring the true size of our galaxy, the scale of the universe becomes even more unbelievable. Our home galaxy is called the Milky Way. On a clear night far from city lights, you can actually see part of it stretching across the sky as a faint band of light. For thousands of years, people wondered what this glowing river was. Ancient civilizations created myths and legends to explain it. The truth turned out to be far more extraordinary. That pale band is not a cloud. It is not dust. It is the combined light of enormous numbers of stars packed together across the disk of our galaxy. And our Sun is only one of them. For a long time, humans believed the stars we could see represented most of the universe. Then better telescopes revealed a shocking reality. The Milky Way contains hundreds of billions of stars. Not thousands. Not millions. Hundreds of billions. Trying to imagine such a number is nearly impossible. If you counted one star every second without ever stopping to eat, sleep, or rest, it would take thousands of years just to count a tiny fraction of the stars in our galaxy. Some of these stars are larger than the Sun. Others are smaller. Some are young and brilliant blue. Others are ancient red stars slowly approaching the ends of their lives. Many likely possess planetary systems of their own, which raises an exciting possibility. If planets are common around stars, then the galaxy may contain countless worlds. Some may be frozen wastelands. Some may be covered in oceans. Some may resemble Earth in ways we have not yet discovered. And somewhere among those worlds, life could exist. But before we even think about alien civilizations, we must confront another astonishing fact. The Milky Way itself is enormous. The solar system sits roughly halfway between the galactic center and the outer edge. We orbit the center of the galaxy at incredible speed. The Sun, Earth, and every planet are moving through space together as part of this giant cosmic structure. Yet despite traveling at hundreds of thousands of kilometers per hour, one complete orbit around the galaxy takes roughly 230 million years. To put that into perspective, when dinosaurs ruled Earth, our solar system was located in a completely different region of the galaxy. Human civilization has existed for only a tiny fraction of a single galactic year. The scale is difficult to grasp. If you could travel at the speed of light, crossing the Milky Way from one side to the other would still require around 100,000 years. Remember, light is the fastest thing known to exist. Even at that unimaginable speed, the journey would take longer than recorded human history. This is where many people realize something unsettling. We often imagine ourselves as explorers standing at the edge of discovery. In reality, humanity occupies a very small corner of an incredibly large galaxy. Most of the Milky Way has never been visited. Most of it has never been observed in detail. Countless stars remain unexplored. Countless planets remain unknown. Entire regions exist that humanity may not study closely for generations. And yet, as enormous as the Milky Way seems, it is not the universe. Not even close. For much of human history, astronomers believed our galaxy might be everything. Then, during the 20th century, powerful observations revealed something that changed our understanding forever. Those faint blurry patches visible through telescopes were not clouds inside the Milky Way. They were galaxies. Entire galaxies. Each containing billions or even hundreds of billions of stars. Suddenly, the universe became much larger than anyone had imagined. The Milky Way was no longer the whole story. It was merely one island in a vast cosmic ocean. And the distance separating these islands makes the gap between stars seem almost insignificant. The nearest star is measured in light years. The nearest major galaxies are measured in millions of light years. The numbers become so extreme that ordinary intuition completely fails. Yet this is only the beginning. Because once humanity discovered other galaxies, a new question emerged. How many of them are out there? The answer would prove more staggering than almost anyone expected. The answer would prove more staggering than almost anyone expected. For centuries, humanity's view of the universe was limited by the power of its eyes. Even after the invention of the telescope, astronomers could only see a tiny fraction of what was actually out there. The night sky appeared filled with stars, but beyond them lay mysteries hidden in the darkness. Then our instruments improved. Larger telescopes revealed more distant objects. Better cameras captured fainter light. Gradually, the universe began to reveal its true scale. And what astronomers discovered was astonishing. The Milky Way was not alone. Every direction they looked contained other galaxies. Some were large spiral galaxies similar to our own. Others were small and irregular. Some contained only a few billion stars, while others possessed trillions. At first, scientists thought there might be a few million galaxies in the observable universe. Then better observations increased the estimate. Millions became billions. Billions became hundreds of billions. And eventually, some studies suggested there could be trillions of galaxies spread throughout the observable cosmos. Each one filled with stars. Each star potentially surrounded by planets. Each planet carrying its own possibilities. The numbers quickly become overwhelming. Imagine taking every grain of sand on a beach. Now imagine that every grain represents an entire galaxy. Not a star. Not a planet. An entire galaxy containing billions of suns. That comparison begins to hint at the true scale of reality. And yet even that analogy falls short. Because galaxies themselves are separated by enormous distances. The nearest major galaxy to the Milky Way is the Andromeda Galaxy. It lies approximately 2.5 million light-years away. Remember how extraordinary 4.24 light-years seemed when discussing the nearest star? Now compare that with 2.5 million. The gap is so large that the human mind struggles to process it. If Proxima Centauri feels distant, Andromeda feels almost unreachable. Light leaving Andromeda today will not arrive on Earth for millions of years. In fact, the light entering telescopes right now began its journey long before modern humans existed. When astronomers observe Andromeda, they are seeing a version of it from the distant past. This strange relationship between distance and time appears everywhere in astronomy. The farther we look into space, the farther back in history we travel. Some of the most distant galaxies ever observed appear as they existed billions of years ago. Their light started moving across the universe before Earth even formed. Before the oceans existed. Before the sun was born. Before our planet was anything more than material waiting to become part of a future solar system. This means that when astronomers study the deepest regions of space, they are effectively examining the early universe itself. The cosmos preserves its own history in light. Every distant object acts as a message from another era. And the deeper we look, the older those messages become. But there is another consequence of these immense distances. Communication becomes nearly impossible. If a civilization existed around Proxima Centauri and sent a message toward Earth today, it would take more than 4 years to arrive. A reply would require another 4 years. Even a simple conversation would take nearly a decade. Across greater distances, the delay becomes far worse. Messages exchanged between galaxies would require millions of years. Civilizations could appear and vanish before receiving responses. The universe is not only vast. It is slow. Distance controls everything. Travel. Communication. Exploration. Discovery. The sheer scale of space creates barriers unlike anything found on Earth. Yet despite all these challenges, humanity has never stopped looking outward. We continue building larger telescopes. We continue searching for distant worlds. We continue asking questions about our place in the cosmos. Because every new discovery reveals something remarkable. The universe is not just larger than we expected. It is larger than previous generations could even imagine. And among all the objects humanity has sent into space, one small spacecraft has helped us appreciate that reality more than almost anything else. A machine launched in the 1970s. A machine still traveling today. A machine called Voyager. And its journey is about to show us what it truly means to leave home behind. And its journey is about to show us what it truly means to leave home behind. When most people think about space exploration, they imagine astronauts walking on the moon, massive rockets launching into the sky, or futuristic missions heading toward Mars. Few realize that the most distant human-made object is neither crude nor modern. It is a spacecraft launched nearly half a century ago. A machine built with technology far less powerful than the smartphone in your pocket. Yet despite its age, it has traveled farther than anything humanity has ever created. Its name is Voyager 1. To understand why Voyager is so remarkable, we need to go back to the 1970s. At the time, scientists noticed something extraordinary. The giant outer planets were approaching a rare alignment. Jupiter, Saturn, Uranus, and Neptune would soon occupy positions that created a unique opportunity for exploration. This arrangement does not happen often. In fact, it occurs only once every few generations. For mission planners, it was the opportunity of a lifetime. By carefully navigating around each planet, a spacecraft could use gravity itself as a source of acceleration. Instead of relying solely on fuel, it could steal a tiny amount of momentum from a planet and use it to increase its own speed. This technique became known as a gravity assist. The concept was brilliant. A spacecraft could visit multiple planets while carrying far less fuel than would otherwise be required. The planets themselves would act like giant cosmic slingshots. Scientists quickly realized the potential. If everything worked perfectly, humanity could explore much of the outer solar system during a single mission. The result was the Voyager program. Two nearly identical spacecraft were constructed: Voyager 1 and Voyager 2. Interestingly, Voyager 2 launched first. Voyager 1 launched a few weeks later but followed a faster trajectory. This allowed it to reach Jupiter and Saturn sooner. At launch, nobody knew exactly how successful the mission would become. The spacecraft were designed to survive only a limited period of time. Certainly not decades. And yet, year after year, they continued operating. As Voyager approached Jupiter, the largest planet in the solar system, it began sending back images unlike anything humanity had ever seen. Before Voyager, many features of Jupiter remained mysterious. Astronomers could observe the planet through telescopes, but they lacked close-up details. Voyager changed everything. The spacecraft revealed enormous storms swirling through the atmosphere. Cloud bands stretched across the giant world. The famous Great Red Spot appeared in stunning detail. Scientists realized that Jupiter was far more complex than previously believed. But the planet itself was only part of the story. Jupiter possesses dozens of moons. Several of them turned out to be extraordinary. One moon in particular shocked the scientific community. Its name was Io. Scientists expected a frozen, inactive world. Instead, Voyager discovered something no one had ever seen beyond Earth. Active volcanoes. Massive eruptions blasted material hundreds of kilometers into space. For the first time in history, active volcanism had been observed on another world. The discovery transformed planetary science overnight. Suddenly, the outer solar system seemed far more dynamic than expected. Then came Europa. At first glance, Europa looked like a frozen ball of ice. But Voyager's observations hinted at something hidden beneath the surface. Long cracks stretched across the moon. Strange patterns covered the icy shell. Scientists began to wonder whether an ocean might exist underneath. An entire sea concealed beneath kilometers of ice. Today, Europa remains one of the most promising places in the solar system where extraterrestrial life could potentially exist. And that possibility can be traced back to observations made during Voyager's mission. Every new image challenged old assumptions. Every new discovery revealed unexpected complexity. The farther Voyager traveled, the more it became clear that the solar system was not simply a collection of planets. It was a collection of worlds. Each unique. Each mysterious. Each deserving exploration. And Voyager was only getting started. Because ahead lay Saturn, one of the most beautiful objects in the entire solar system. A world surrounded by vast rings stretching hundreds of thousands of kilometers through space. A world that would reveal even more surprises. And after Saturn, Voyager would continue toward a destination no spacecraft had ever reached before. The edge of the Sun's domain itself. The edge of the Sun's domain itself. Before Voyager could begin that historic journey, it first had to encounter one of the most spectacular planets ever discovered. Saturn. For thousands of years, Saturn appeared as little more than a bright point of light moving slowly across the night sky. Ancient observers had no idea that it possessed one of the most extraordinary features in the solar system. Its rings. Even after the invention of the telescope, those rings remained mysterious. Early astronomers struggled to understand what they were seeing. Some thought Saturn had giant handles attached to its sides. Others believed multiple objects orbited close together. It took centuries before scientists realized the truth. Saturn was surrounded by an enormous system of rings made from countless pieces of ice and rock. Yet even then, many questions remained unanswered. How large were the rings? How old were they? How were they structured? From Earth, even powerful telescopes could provide only limited details. Voyager changed that. As the spacecraft approached Saturn in 1980, anticipation grew throughout the scientific community. The mission had already transformed our understanding of Jupiter and its moons. Now it was about to examine another giant world from close range. The images that arrived were breathtaking. Saturn appeared unlike anything else in the solar system. Its pale golden atmosphere wrapped around a massive globe nearly 10 times wider than Earth. The rings stretched outward in graceful arcs, creating one of the most beautiful sights ever captured by a spacecraft. But beauty was only part of the story. Voyager revealed details no one had ever seen before. Instead of a few simple rings, Saturn possessed thousands of individual ring structures. Some were bright. Some were dark. Some contained mysterious gaps. Others displayed intricate patterns shaped by gravity. The entire system turned out to be far more complex than scientists expected. Imagine billions upon billions of icy fragments orbiting together in a delicate balance. Some pieces were no larger than grains of sand. Others were as large as houses. Together they formed a structure so vast that it could stretch across enormous distances while remaining astonishingly thin. In many places, the rings were only tens of meters thick. A gigantic structure with the thickness of a building. Nature had created something almost impossible to imagine. Yet Saturn still held more surprises. The planet's moons attracted enormous attention. Among them was one particularly fascinating world. Titan. Titan was already known to be unusual because it possessed a dense atmosphere. Most moons in the solar system are airless. Titan was different. Voyager revealed that its atmosphere was so thick that the surface could not be seen directly. A permanent orange haze covered the entire moon. Scientists immediately became intrigued. What existed beneath those clouds? Mountains? Oceans? Ice fields? No one knew. The mystery would remain for years. Yet Voyager's observations established Titan as one of the most important destinations for future exploration. Decades later, additional missions would finally reveal its secrets. And those secrets turned out to be astonishing. Titan contains rivers, lakes, rain, and weather systems. But not made of water. Made of liquid methane and ethane. An alien version of Earth's water cycle operating in the deep cold of space. Even today, Titan remains one of the strangest worlds ever discovered. As Voyager continued its investigation of Saturn's system, scientists realized something important. The solar system was far more diverse than anyone had imagined. Each planet was unique. Each moon told a different story. Some worlds were covered in volcanoes. Some concealed oceans beneath ice. Others possessed thick atmospheres and weather unlike anything found on Earth. The farther Voyager traveled, the less ordinary the solar system seemed. And now a major decision approached. Mission planners faced a choice that would shape the future of space exploration. Voyager 1 could continue studying Saturn and Titan in greater detail. But doing so would alter its trajectory. The spacecraft would no longer be able to visit Uranus and Neptune. Instead, it would be directed toward a path leading out of the solar system. Scientists chose Titan. The decision was risky. But the scientific value was too great to ignore. As a result, Voyager 1 began a new journey. Not toward another planet, but toward interstellar space itself. Meanwhile, another spacecraft was preparing to continue the grand tour. Voyager 2. And unlike its twin, Voyager 2 was about to become the first and only spacecraft in history to visit two mysterious worlds that humanity had never seen up close. Uranus and Neptune. Uranus and Neptune. Even today, these two planets remain among the least explored worlds in the solar system. Unlike Jupiter and Saturn, they are so distant that reaching them requires years of travel. Sunlight becomes weak in these remote regions. Temperatures fall dramatically. The familiar warmth of the inner solar system fades into an endless cold darkness. Before Voyager 2 arrived, humanity knew surprisingly little about either planet. Astronomers could observe them through telescopes, but they appeared only as small, distant disks. Most of what existed there remained a mystery. And yet Voyager 2 continued moving outward. farther than any spacecraft had ever traveled before. Year after year, it crossed immense distances through the darkness. The sun gradually shrank behind it. The giant planets became memories. Ahead waited a world unlike anything previously encountered. Uranus. When Voyager 2 finally approached the planet in 1986, scientists immediately noticed something strange. Uranus appeared calm. Almost too calm. Unlike Jupiter's swirling storms or Saturn's dramatic cloud patterns, Uranus seemed quiet and featureless. At first glance, it looked like a smooth blue-green sphere floating in space. But appearances can be deceptive. The most remarkable feature of Uranus was not visible in a simple photograph. It was the way the planet rotated. Every major planet in the solar system spins in a relatively upright orientation. Uranus does not. Instead, the planet appears to have been knocked over. Its axis is tilted by approximately 98 degrees. Imagine Earth rotating while lying almost completely on its side. That is essentially what Uranus does. As a result, its seasons are unlike anything found elsewhere in the solar system. Some regions experience decades of continuous sunlight. Others remain in darkness for equally long periods. Entire hemispheres can spend years facing the sun before slowly turning away again. No world discovered before had behaved like this. Scientists still debate exactly what happened. One leading theory suggests that a colossal collision occurred billions of years ago. A massive object may have struck Uranus during the early formation of the solar system. The impact could have been powerful enough to permanently alter the planet's orientation. If true, Uranus carries the scars of an ancient catastrophe. But the surprises did not end there. Voyager revealed that Uranus possessed rings. Although much darker and less obvious than Saturn's, they were real. Thin structures encircled the planet. Several previously unknown moons were also discovered. The more scientists examined Uranus, the more complex it became. Yet Voyager could not remain there forever. Its momentum carried it onward. Toward the final major planet in the solar system. A world even farther away. A world that no spacecraft had ever visited. Neptune. The journey required several more years. By now Voyager 2 was operating at distances almost impossible to comprehend. Radio signals needed hours to travel between Earth and the spacecraft. Command sent from mission control crossed billions of kilometers before arriving. The spacecraft was becoming increasingly isolated. And still it continued. Finally, in 1989, Voyager reached Neptune. What scientists found immediately challenged expectations. If Uranus appeared calm, Neptune was the opposite. Despite receiving far less sunlight than Earth, Neptune possessed some of the most violent weather ever observed. Massive storms churned through its atmosphere. Dark cloud systems moved across the planet. Powerful winds raced at incredible speeds. Some exceeded 2,000 kilometers per hour. These were the fastest planetary winds ever measured. The discovery shocked researchers. How could a world so far from the sun generate such energetic weather? Even today, scientists continue investigating that question. Neptune proved that distance from the sun does not necessarily mean inactivity. The outer solar system remained alive with dynamic processes. Then Voyager encountered another extraordinary object. Neptune's largest moon. Triton. At first glance, Triton appeared frozen and lifeless. But close observations revealed something unexpected. The moon was active. Voyager detected enormous plumes rising above the surface. Material erupted into the thin atmosphere and drifted across the landscape. It was the first evidence of active geyser-like activity on Triton. Another supposedly frozen world had turned out to be surprisingly complex. By this point, Voyager 2 had achieved something unprecedented. It had visited all four giant planets: Jupiter, Saturn, Uranus, and Neptune. No other spacecraft has accomplished this. Even decades later, Voyager 2 remains the only visitor ever to explore Uranus and Neptune up close. Its discoveries transformed our understanding of the outer solar system. But perhaps the most remarkable part of the story was still ahead. The grand tour of the planets was ending. The age of interstellar exploration was about to begin. And beyond Neptune stretched a region more lonely, more distant, and more mysterious than anything Voyager had encountered before. The vast frontier between the stars. The vast frontier between the stars. For centuries, humanity's maps ended at the edges of the known world. Beyond those boundaries existed uncertainty. Sailors feared the unknown oceans. Explorers wondered what waited beyond distant horizons. Voyager faced a similar challenge. After Neptune, there were no more planets waiting ahead. No giant worlds. No dramatic flybys. No future encounters carefully planned years in advance. Instead, the spacecraft entered a region where distances became even more extreme and familiar landmarks disappeared. The solar system was beginning to fade behind it. Most people imagine the solar system as a collection of planets orbiting the Sun. In reality, the planets occupy only a tiny portion of the Sun's overall domain. Far beyond Neptune lies a vast region filled with icy remnants left over from the birth of the solar system. These ancient objects are among the oldest surviving material in our cosmic neighborhood. They formed billions of years ago when the planets themselves were still taking shape. Many remain unchanged to this day. Frozen records of a distant era. For decades, scientists suspected that enormous numbers of these objects existed beyond the major planets. Today, we know this region as the Kuiper Belt. It stretches across a huge area beyond Neptune and contains countless icy bodies moving through darkness. Some are relatively small. Others are surprisingly large. One of the most famous is the dwarf planet Pluto. Although Pluto is no longer classified as a major planet, it remains one of the most fascinating objects in the outer solar system. Voyager never visited Pluto. Its trajectory carried it in a different direction. But as it moved beyond Neptune, it entered the same distant realm where Pluto resides. A region where sunlight is weak and temperatures approach unimaginable levels of cold. Out there, the sun no longer dominates the sky. From Earth, sunlight floods every day with overwhelming brightness. Near Neptune, however, the sun appears much smaller. Farther still, it becomes just another bright star among countless others. Imagine standing on a frozen world billions of kilometers from Earth. The sun would no longer feel like the center of everything. It would simply be a brilliant point of light shining in a sea of darkness. That realization reveals how small our place in the universe truly is. Even after traveling beyond all the major planets, Voyager was still inside the sun's sphere of influence. The solar system extends much farther than most people realize. In fact, if the orbit of Neptune were represented by a single step, the true outer boundary of the solar system might require thousands more. The planets occupy only a small fraction of the entire journey. As Voyager pushed onward, communication became increasingly difficult. Radio signals required longer and longer travel times. Engineers on Earth had to be patient. A command sent to the spacecraft could take many hours to arrive. The response would require additional hours to return. Conversations between Earth and Voyager had effectively become exchanges across an immense cosmic gulf. Yet the spacecraft continued functioning. Year after year. Decade after decade. Its systems endured harsh conditions no machine had ever experienced before. Temperatures plunged. Energy gradually declined. But Voyager kept moving. And with every passing year, it carried humanity farther into unexplored territory. By now, another remarkable fact was becoming clear. Voyager was not merely traveling through space. It was approaching a boundary. A border separating two enormous regions of the cosmos. On one side existed the sun's domain. On the other lay interstellar space. The space between stars. For generations, astronomers had studied this boundary from afar. They could estimate where it might exist. They could build models and theories. But no spacecraft had ever reached it. No instrument had ever crossed it. No human-made object had entered that unknown frontier. Voyager was heading directly toward it. And as the spacecraft approached, scientists prepared for one of the most important moments in the history of exploration. A moment comparable to crossing an ocean and reaching a new continent. A moment when humanity would extend its presence beyond the protective bubble created by the sun. Because surrounding our entire solar system is an invisible structure. A giant shield produced by the sun itself. A shield that stretches billions of kilometers into space. And Voyager was about to reach its edge. The boundary known as the heliosphere. The boundary known as the heliosphere. At first glance, the sun seems simple. Every morning it rises above the horizon, filling the world with light and warmth. To us, it appears stable and predictable. But the sun is far more active than it looks. Deep within its core, nuclear fusion continuously releases enormous amounts of energy. This energy does not remain confined to the sun itself. A portion escapes into space in the form of charged particles traveling at incredible speeds. This constant stream is known as the solar wind. Unlike the gentle breeze implied by its name, the solar wind is a powerful flow of particles spreading outward in every direction. It races away from the sun at hundreds of kilometers per second, carrying magnetic fields far beyond the orbit of the planets. As the solar wind expands, it creates a vast bubble surrounding the solar system. This bubble is called the heliosphere. For billions of years, Earth and every other planet have existed inside it. Most people never think about the heliosphere because it is invisible. Yet it performs an important role. It acts as a protective shield. Beyond the heliosphere lies interstellar space, a region filled with energetic particles originating from distant stars, supernova explosions, and other violent cosmic events. Many of these particles travel across the galaxy at extraordinary speeds. The heliosphere helps deflect a significant portion of them. In a sense, the sun is not only our source of light. It is also our guardian. Its magnetic influence extends far into the darkness, creating a protective region around our planetary system. But that protection does not continue forever. The farther the solar wind travels, the weaker it becomes. Eventually it encounters material drifting through interstellar space. At that point, a cosmic struggle begins. The outward pressure of the solar wind meets the pressure of the galaxy beyond. Somewhere in that distant frontier, a boundary forms. A place where the sun's influence starts to give way. For decades, scientists debated exactly where this boundary might be located. The distances involved were immense. No spacecraft had ever traveled far enough to investigate it directly. The heliosphere remained one of the great unanswered questions of space science. Then Voyager approached. As the spacecraft moved farther from the sun, its instruments began detecting subtle changes. The environment was no longer behaving the way it had near the planets. Particle levels shifted. Magnetic conditions evolved. The density of surrounding material changed. Voyager was entering a region unlike anything previously explored. One of the first major boundaries scientists expected was the termination shock. This is the point where the solar wind slows dramatically after encountering resistance from the interstellar medium. Imagine a river flowing rapidly until it reaches an obstacle and begins to lose speed. Something similar occurs on a cosmic scale. When Voyager crossed this region, it provided humanity with its first direct measurements of a process that had existed unseen for billions of years. The data was invaluable. For the first time, theories could be tested against reality. Yet the termination shock was only the beginning. Beyond it lay an even stranger region known as the Alio sheath. This vast zone acts as a transition area between the inner solar system and true interstellar space. Conditions there are chaotic. Particles interact in complex ways. Magnetic fields twist and change. The farther Voyager traveled, the more unfamiliar the environment became. It was as though the spacecraft were sailing toward the edge of a continent, approaching waters no explorer had ever crossed. Scientists monitored every transmission carefully. Each signal carried clues about a region humanity had never directly studied before. Years passed. Then more years. Voyager continued moving through the Alio sheath, inching closer to a historic milestone. Many researchers wondered when the crossing would finally occur. Would it happen soon? Would it take decades? Nobody knew for certain. The boundary itself was invisible. There would be no signpost floating in space. No dramatic line marking the transition. Instead, scientists would have to identify the crossing through data. Patterns. Measurements. Evidence gathered by instruments traveling billions of kilometers from Earth. Then, after decades of flight, something extraordinary began to happen. The readings started to change in a way no spacecraft had ever observed before. The influence of the solar wind weakened dramatically. At the same time, particles originating from outside the solar system increased. It was exactly the kind of shift researchers had hoped to see. Voyager was approaching a frontier no human-made object had ever crossed. A frontier separating the sun's protective bubble from the immense galaxy beyond. And very soon, humanity would achieve something once thought impossible. For the first time in history, a spacecraft would leave the heliosphere and enter interstellar space. For the first time in history, a spacecraft would leave the heliosphere and enter interstellar space. The moment had been anticipated for decades. Generations of scientists had worked on the Voyager mission. Some of the engineers who helped design the spacecraft had already retired. Others had spent much of their careers waiting for this milestone. Now it was finally approaching. Yet there was a problem. Nobody knew exactly how to identify the crossing. Unlike a national border on Earth, there was no visible line floating in space. Voyager would not pass through a gate or encounter a marker announcing its arrival in interstellar space. The transition would have to be detected through evidence alone. Scientists carefully monitored every piece of data arriving from the spacecraft. The challenge was complicated by distance. By this stage, Voyager was more than 18 billion kilometers from Earth. Radio signals traveled for many hours before reaching our planet. Every message was precious. Every measurement mattered. Researchers searched for signs that the sun's influence was fading and that the environment beyond the heliosphere was beginning to dominate. Then the evidence started to appear. Instruments detected a dramatic increase in high-energy cosmic rays. These particles originated from far beyond the solar system. For years, the heliosphere had shielded Voyager from many of them. Now their numbers were rising. At the same time, particles associated with the solar wind dropped sharply. The change was impossible to ignore. Something significant was happening. Voyager seemed to be entering a completely different region of space. Scientists debated the data intensely. Some believed the crossing had already occurred. Others urged caution. Extraordinary claims required extraordinary evidence. The world watched as researchers analyzed every detail. Then came another crucial discovery. Measurements indicated that the density of surrounding particles had increased dramatically. This matched predictions for interstellar space. The environment around Voyager no longer resembled the interior of the heliosphere. It resembled the galaxy beyond. Finally, in 2012, the conclusion became unavoidable. Voyager 1 had crossed into interstellar space. For the first time in human history, a machine built on Earth had entered the region between the stars. The achievement was extraordinary. Human beings had not physically traveled there. But something created by human hands had. A tiny spacecraft launched in 1977 had become humanity's first interstellar explorer. The announcement captured attention around the world. Yet many people misunderstood what interstellar space actually meant. Voyager had not left the solar system entirely. The solar system extends far beyond the heliosphere. Instead, Voyager had left the sun's protective bubble and entered the broader environment of the Milky Way. It was now traveling through material that exists between star systems. The significance was enormous. For decades, interstellar space had existed only as a distant concept. Now humanity was directly sampling it. Directly measuring it. Directly exploring it. The spacecraft continued transmitting valuable information. Scientists learned more about cosmic rays, magnetic fields, and the structure of the interstellar medium. Questions that had persisted for generations finally began receiving answers. Yet perhaps the most remarkable aspect of the story was Voyager itself. The spacecraft was never designed for such a mission. Its expected lifespan was far shorter. Its computers were primitive by modern standards. Its memory was tiny compared to today's devices. And yet it had accomplished something no newer spacecraft had achieved. It had become the most distant human-made object ever created. Meanwhile, Voyager 2 continued following behind. Years after Voyager 1 crossed the heliosphere, its twin would accomplish the same feat. Together, the two spacecraft became humanity's ambassadors to interstellar space. Still moving. Still transmitting. Still exploring. Every day they traveled farther from Earth. Every day the gap grew larger. And with each passing year, another question became increasingly fascinating. If Voyager continued forever, where would it eventually go? The answer leads us into a future stretching thousands, tens of thousands, and even millions of years ahead. A future in which Voyager may outlive every nation, every city, and perhaps even every language that exists today. A future in which Voyager may outlive every nation, every city, and perhaps even every language that exists today. It is a strange thought. Most things created by human beings are temporary. Buildings eventually collapse. Roads crack and disappear. Entire civilizations leave behind only fragments of their existence. History is filled with lost cities and forgotten empires. Time erases almost everything. Yet Voyager is different. Unlike objects on Earth, Voyager travels through an environment where erosion is extremely slow. There is no atmosphere to rust its metal. There is no rain to wear away its surface. There are no oceans, winds, or biological processes gradually breaking it apart. Space is harsh in many ways, but it is also surprisingly good at preserving things. As a result, Voyager may survive for an astonishingly long time. Not centuries. Not thousands of years. Potentially millions. Long after its instruments fall silent, the spacecraft itself could continue drifting through the galaxy. This raises an intriguing question. Where exactly is Voyager going? The answer surprises many people. Voyager is not heading toward a specific star. Its mission was never designed as an interstellar voyage to another solar system. Instead, it is following a path determined by gravity, momentum, and the trajectory established decades ago during its planetary encounters. At the moment, Voyager 1 is moving at roughly 17 kilometers per second relative to the Sun. That may sound incredibly fast. And by human standards, it certainly is. But on a galactic scale, it is remarkably slow. Remember, the nearest star is more than 4 light-years away. Even at Voyager's tremendous speed, reaching another stellar system would require tens of thousands of years. This is one of the most powerful demonstrations of the vastness of interstellar space. Voyager has been traveling since 1977. For nearly half a century, it has raced outward through the darkness. Yet compared to the distances between stars, it has barely begun the journey. If human history were represented as a single day, Voyager's progress toward the nearest stars would be measured in seconds. The galaxy is simply that large. Nevertheless, scientists have calculated some of Voyager's future encounters. In approximately 40,000 years, Voyager 1 will pass relatively close to a distant star known as Gliese 45. Not close enough to enter its planetary system. Not close enough to perform observations. But close enough to be considered a cosmic flyby. 40,000 years. Consider how much Earth has changed in the last 40,000 years. At that time, humans lived as hunter-gatherers. Agriculture had not yet emerged. Cities did not exist. Written language had not been invented. Everything we call civilization lay in the future. Now imagine another 40,000 years passing. That is the timescale involved in Voyager's journey. The spacecraft operates according to a schedule completely detached from ordinary human experience. Its voyage unfolds across epochs rather than lifetimes. And that is only the beginning. Over hundreds of thousands and millions of years, Voyager will continue orbiting the center of the Milky Way alongside countless stars. The Sun itself is moving through the galaxy. So is Voyager. Everything is in motion. Nothing remains fixed. Eventually, the positions of stars will change dramatically. Constellations familiar to us today will become unrecognizable. Future observers, if any exist, may look at entirely different night skies. Yet Voyager will still be traveling, silently crossing the darkness. This realization often changes the way people think about time. Human lives are brief. Even entire civilizations are brief compared to cosmic history. The universe operates on scales that dwarf our everyday experience. Millions of years. Billions of years. Time periods so large that they become difficult to comprehend. And Voyager serves as a reminder of that reality. A small machine built by a young technological civilization. A machine that may continue its voyage long after the creators who launched it have vanished into history. But Voyager is carrying something even more remarkable than its instruments. Something deliberately placed aboard the spacecraft before launch. A message. A record of humanity itself. A collection of sounds, images, and greetings intended for anyone, or anything, that might someday discover it. Known simply as the Golden Record. And among all the items aboard Voyager, it may ultimately become the spacecraft's most important legacy. Known simply as the Golden Record. And among all the items aboard Voyager, it may ultimately become the spacecraft's most important legacy. When scientists and engineers were preparing the Voyager mission in the 1970s, they faced an unusual question. If these spacecraft were destined to travel farther than anything humanity had ever built, should they carry a message? Not a scientific report. Not technical data. A message from Earth itself. The idea sounded almost impossible. How could an entire planet be represented by a single object? How could billions of people, thousands of cultures, and countless experiences be condensed into something small enough to fit aboard a spacecraft? Yet the team decided to try. The result became one of the most fascinating artifacts ever created. A gold-plated copper phonograph record attached to each Voyager spacecraft. The Golden Record was designed as a kind of cosmic time capsule. Its purpose was simple. If another intelligent civilization ever discovered Voyager, the record might tell them something about the beings who created it. Whether anyone will ever find it remains unknown. The odds are incredibly small. Space is unimaginably vast. Voyager is tiny. The galaxy contains enormous distances and endless emptiness. Yet the creators of the record believed the effort was worthwhile. Not because discovery was guaranteed, but because the message itself represented something important. Hope, curiosity, and humanity's desire to connect with the unknown. The record contains a remarkable collection of information. Images, sounds, music, greetings, scientific diagrams, all carefully selected to provide a glimpse of life on Earth. There are photographs showing mountains, oceans, forests, and deserts. Images of animals, plants, human beings, scenes from everyday life. The goal was not to present a perfect picture of humanity. Such a thing would be impossible. Instead, the record attempts to capture fragments of our world. Moments from a civilization living on a small planet orbiting an ordinary star. The sounds included on the record are equally fascinating. Waves crashing against a shore. Wind. Thunder. Birdsong. Animal calls. The sounds of nature that have surrounded life on Earth for millions of years. There are also sounds created by humans. Footsteps. Laughter. Tools. Machines. Music. Many forms of music. Classical compositions. Traditional performances. Cultural expressions from different parts of the world. The creators wanted the record to reflect the diversity of human civilization. No single song could represent humanity. No single language could speak for everyone. So they included many voices. One of the most famous parts of the record is a collection of greetings spoken in numerous languages. People from different cultures offer simple messages of peace and friendship. These greetings travel through the galaxy aboard Voyager even today. Imagine that for a moment. Words spoken on Earth decades ago are now moving through interstellar space. Far beyond the planets. Far beyond the heliosphere. Far beyond anything those speakers could ever physically visit. Perhaps the most remarkable aspect of the Golden Record is what it says about humanity itself. The record was never intended as a practical communication device. The chances of another civilization discovering it are extraordinarily low. Scientists understood this from the beginning. The record was symbolic. It represented a civilization looking outward. A species asking questions. A species wondering whether it is alone. In many ways, the Golden Record tells us as much about ourselves as it would about any potential finder. It reveals what humanity considered important. What humanity considered beautiful. What humanity wanted to preserve. If Earth vanished tomorrow, the Golden Record would still exist, carrying traces of our world through the darkness. A tiny archive drifting among the stars. And that raises another fascinating question. If intelligent civilizations do exist elsewhere in the galaxy, why haven't we found any evidence of them? The Milky Way contains hundreds of billions of stars. Many likely possess planets. Some of those planets may be billions of years older than Earth. Given those numbers, one possibility seems difficult to ignore. Perhaps we should have found someone by now. Perhaps someone should have found us. Yet the universe remains silent. A mystery that has puzzled scientists for generations. A mystery known as the Fermi Paradox. A mystery known as the Fermi Paradox. In the summer of 1950, physicist Enrico Fermi was having a casual conversation with colleagues when he asked a question that would become one of the most famous in science. Where is everybody? At first glance, the question seemed simple. But behind it lay a profound mystery. The universe is unimaginably large. The Milky Way alone contains hundreds of billions of stars. Many of those stars are older than the Sun. Many are likely surrounded by planets. Some of those planets may possess conditions suitable for life. Given enough time, it seems reasonable to imagine that intelligent civilizations could emerge elsewhere in the galaxy. And if even a small fraction of those civilizations developed advanced technology, some might eventually explore space. Some could build probes. Some might colonize nearby star systems. Others could spread gradually across large portions of the galaxy. The numbers appear to support this possibility. After all, the Milky Way is more than 13 billion years old. Human civilization, by comparison, has existed for only a tiny fraction of that time. If another civilization gained even a modest head start, it could be millions of years more advanced than we are today. That thought leads directly to Fermi's question. If intelligent life is common, where is the evidence? Why haven't we detected clear signals? Why haven't we observed alien spacecraft? Why don't we see signs of vast interstellar civilizations? The contradiction between expectation and observation became known as the Fermi Paradox. The paradox does not prove that alien civilizations do not exist. Instead, it highlights the gap between what many scientists expect and what we actually observe. Over the decades, researchers have proposed countless possible explanations. Some are optimistic. Others are unsettling. One possibility is that intelligent life is extremely rare. Perhaps simple life emerges relatively often, but the transition to complex organisms is extraordinarily difficult. Maybe the chain of events that led to human intelligence was so unlikely that it rarely happens elsewhere. If that is true, Earth could be one of the few worlds where intelligent beings ever evolved. Another possibility is that civilizations do arise frequently but do not survive for long. Technological societies may face challenges that eventually destroy them. Environmental collapse. Resource depletion. War. Artificial intelligence. Unknown dangers we have not yet imagined. In this scenario, civilizations appear throughout the galaxy but disappear before spreading among the stars. Some scientists refer to this possibility as the Great Filter, a barrier that prevents most civilizations from reaching advanced interstellar stages. The unsettling question is whether that filter lies behind us or ahead of us. If it lies behind us, humanity may have already passed one of the rarest hurdles in cosmic history. If it lies ahead, our greatest challenges may still be waiting. There is also a simpler explanation. Perhaps the galaxy is simply too large. The distances between stars are enormous. As Voyager demonstrated, even reaching the nearest stellar neighbors requires extraordinary timescales. Interstellar travel may be so difficult that very few civilizations attempt it. Even advanced species could remain isolated within their own systems, separated not by hostility, but by distance. Another possibility is that signals from alien civilizations exist, but we have not detected them yet. Humanity has been listening seriously for only a short time. Compared to the age of the galaxy, our search has barely begun. It is possible that evidence is already out there, hidden within data we have not yet analyzed or arriving from directions we have not yet examined. Then there is perhaps the strangest idea of all. What if advanced civilizations deliberately remain silent? What if they observe without revealing themselves? What if the galaxy contains intelligence, but not the kind we expect? These possibilities belong more to speculation than established science, yet they demonstrate how many unanswered questions remain. The truth is that nobody knows. And that uncertainty is part of what makes the mystery so compelling. Every new telescope, every new mission, every new discovery has the potential to change our understanding completely. Perhaps tomorrow we will find evidence of life on a distant world. Perhaps we will discover microbial organisms within our own solar system. Or perhaps the silence will continue. For now, Voyager carries humanity's message into the darkness with no guarantee that anyone will ever hear it. A tiny ambassador traveling through an ocean of stars. An ocean that may be filled with countless civilizations. Or perhaps none at all. And as scientists search for answers, another question becomes increasingly important. If humanity ever hopes to reach those distant stars, how could such a journey actually be accomplished? Because the technologies we use today are nowhere near fast enough. Because the technologies we use today are nowhere near fast enough. This is one of the most difficult realities in all of space exploration. Humanity has built incredible machines. We have sent spacecraft to every major planet in the solar system. We have landed robots on Mars. We have placed telescopes millions of kilometers from Earth. We have even sent Voyager into interstellar space. Yet despite all of these achievements, the stars remain frustratingly distant. The problem is speed. More specifically, the lack of it. On Earth, speed solves almost every transportation problem. If a journey takes too long, we build faster vehicles. Ships become airplanes. Cars become high-speed trains. Technology shrinks distances. But space is different. The distances are so extreme that even enormous improvements in speed often make surprisingly little difference. Consider Voyager. Since its launch in 1977, it has traveled farther than any human-made object in history. For decades it has raced away from the Sun at extraordinary velocity. Yet even after nearly half a century of continuous travel, it has not come remotely close to another star. That fact alone demonstrates the scale of the challenge. The nearest star remains more than 4 light-years away. At Voyager's speed, the journey would require tens of thousands of years. Clearly, something faster is needed. Much faster. Scientists have proposed many solutions over the years. Some involve improving existing rocket technology. Others require entirely new forms of propulsion. One of the most famous concepts is the nuclear spacecraft. Traditional rockets burn chemical fuel. This approach works well for launching from Earth, but chemical reactions have limits. To reach the stars, many researchers believe we may eventually need to harness the energy stored within atomic nuclei. Nuclear propulsion could potentially accelerate spacecraft to speeds far beyond those achievable today. Some designs use nuclear reactors. Others rely on controlled fusion reactions similar to those powering the Sun. Theoretically, such systems could reduce interstellar travel times dramatically. Yet even these advanced concepts face enormous engineering challenges. Building them safely remains difficult. Operating them reliably may prove even harder. Then there are ideas that sound almost like science fiction. One example involves giant sails. Not sails powered by wind. Sails powered by light. Photons carry momentum. Although the force is extremely small, it exists. Over long periods, a large reflective sail could gradually accelerate through space without carrying enormous quantities of fuel. Scientists have seriously studied this possibility. Some proposed designs would use powerful lasers located near Earth to push tiny spacecraft to incredible speeds. If successful, such missions might reach nearby stars within a human lifetime. Another concept involves antimatter. When matter and antimatter meet, they release tremendous amounts of energy. In theory, antimatter propulsion could be among the most efficient methods ever conceived. Unfortunately, producing and storing antimatter remains extraordinarily difficult. Current technology can create only tiny amounts. Practical antimatter starships remain far beyond our capabilities. And even if propulsion problems are solved, another challenge appears. Human survival. A trip lasting decades or centuries raises questions unlike any previous journey. How would crews obtain food? How would they maintain equipment? How would societies function aboard enormous spacecraft isolated from Earth? One proposed solution is the generation ship. A vessel so large that multiple generations live and die during the voyage. The people arriving at the destination would not be the same individuals who departed. Instead, their descendants would complete the mission. Another possibility involves suspended animation. Science fiction often portrays travelers sleeping through long journeys. While no such technology currently exists for humans, researchers continue exploring related concepts. If future breakthroughs occur, interstellar travel could become more practical. For now, however, these ideas remain theoretical. The stars continue to challenge us. Not because they are unreachable in principle, but because the distances involved are unlike anything humanity has ever confronted. And yet history suggests caution when declaring something impossible. Only a century ago, powered flight was new. The moon seemed unattainable. Space exploration itself belonged largely to imagination. Then technology advanced. What once appeared impossible became reality. Perhaps the same will happen with the stars. Perhaps future generations will develop methods we cannot yet imagine. Methods that transform interstellar travel from a dream into a routine activity. But even if humanity eventually reaches nearby stars, another question remains. What exactly might we find when we arrive? Because the planets orbiting other suns are no longer just speculation. Today, astronomers know they are real. And some of them may be surprisingly similar to Earth. Today, astronomers know they are real. And some of them may be surprisingly similar to Earth. For most of human history, nobody knew whether planets existed around other stars. The idea seemed reasonable, but there was no proof. When people looked at the night sky, they saw countless stars shining in the darkness. Yet nobody could say with certainty whether those distant suns possessed worlds of their own. The answer remained hidden for centuries. Then technology finally caught up with curiosity. In the 1990s, astronomers began discovering the first confirmed planets orbiting stars beyond our solar system. These worlds became known as exoplanets. The discoveries changed astronomy forever. At first, scientists expected exoplanets to resemble the familiar planets of our own system. Instead, they found something astonishing. The universe was far stranger than anyone had imagined. Some planets were enormous gas giants orbiting incredibly close to their stars. Others traveled along bizarre paths unlike anything seen in the solar system. There were worlds heated to temperatures capable of melting metal. Worlds covered in thick clouds. Worlds larger than Jupiter. Worlds smaller than Earth. Every new discovery seemed to reveal another surprise. And then the numbers began to explode. As telescopes improved, more planets appeared. Hundreds. Then thousands. Then thousands more. Today, astronomers have confirmed the existence of well over 5,000 exoplanets, and they suspect billions more remain undiscovered throughout the Milky Way. That realization transformed a fundamental question. For generations, people wondered whether planets existed around other stars. Now the question became different. How many of those planets could support life? To answer it, scientists focused on a concept known as the habitable zone. This is the region around a star where temperatures may allow liquid water to exist on a planet's surface. Too close to the star, and water evaporates. Too far away, and it freezes solid. Between those extremes lies a potentially favorable region. Earth happens to orbit within the habitable zone of the Sun. And astronomers have identified numerous exoplanets that appear to orbit within similar regions around their own stars. Some of these worlds have attracted enormous attention. One of the most famous is located around Proxima Centauri, the nearest star to the solar system. Known as Proxima Centauri b, this planet is roughly Earth-sized and orbits within its star's habitable zone. The discovery generated excitement across the scientific community. For the first time, humanity had identified a potentially habitable world around the nearest star. Of course, habitability does not guarantee life. A planet may exist in the right location while still being completely hostile. Atmospheres matter. Magnetic fields matter. Geology matters. Countless factors influence whether a world can support living organisms. Yet the discovery was still remarkable. It suggested that Earth-like planets may not be rare. They may be common. And if Earth-like planets are common, the implications are profound. The Milky Way contains hundreds of billions of stars. Even if only a small percentage possess habitable worlds, the number of potentially life-friendly planets could be enormous. Millions. Perhaps billions. Suddenly, humanity no longer seemed like an isolated exception. Instead, we appeared to be part of a galaxy filled with possibilities. Some astronomers believe the coming decades may revolutionize our understanding of these distant worlds. New telescopes are becoming increasingly powerful. Future instruments may analyze the atmospheres of exoplanets in extraordinary detail. Scientists hope to search for chemical signatures associated with life. Oxygen. Methane. Other compounds that could indicate biological activity. Imagine the impact of such a discovery. Not intelligent aliens. Not advanced civilizations. Simply evidence that life exists elsewhere. Even the detection of microscopic organisms on another world would fundamentally change humanity's understanding of its place in the universe. It would mean that life is not unique to Earth. That biology emerged at least twice. And if it happened twice, perhaps it happened many times. For now, however, these distant planets remain beyond our reach. Voyager will never visit them. No current spacecraft can. The gap between us and the stars remains immense. Yet every year, astronomers learn more. Every year, the map of the galaxy becomes richer. And every year, another possibility grows more intriguing. Perhaps somewhere among those countless worlds, another civilization is looking toward the sky and asking the same questions we are. Questions about distance. Questions about life. Questions about whether anyone else is out there. And if such civilizations exist, there is one universal challenge they must face as well. The challenge of communicating across the unimaginable emptiness between the stars. The challenge of communicating across the unimaginable emptiness between the stars. Distance does not only make travel difficult. It also makes conversation difficult. On Earth, communication feels almost instantaneous. Messages travel across continents in fractions of a second. Video calls connect people separated by oceans. Information moves so quickly that most of us rarely think about the time required for a signal to travel. But space changes everything. The farther apart two civilizations are, the more important distance becomes. Even light has limits. And that simple fact creates one of the greatest obstacles any advanced civilization must overcome. Imagine that humanity receives a message from a civilization living around Proxima Centauri. The signal arrives on Earth after traveling through space for more than 4 years. Scientists decode it and immediately send a reply. Then they wait. And wait. And wait. More than 4 additional years pass before the response reaches its destination. A simple exchange of greetings requires nearly a decade. One question. One answer. 10 years. Suddenly, communication no longer resembles a conversation. It becomes something entirely different. Now imagine a civilization located 100 light-years away. A message takes a century to arrive. A reply requires another century. The full exchange spans 200 years. The individuals who sent the original message may be long gone before receiving an answer. For civilizations separated by thousands of light-years, the situation becomes even more extreme. Communication transforms into an interaction between generations rather than individuals. The galaxy is simply too large. This reality often surprises people. Science fiction frequently portrays civilizations communicating effortlessly across interstellar distances. In reality, the speed of light creates a universal speed limit. As far as modern physics can tell, nothing carrying information can exceed it. That limit shapes the structure of the universe itself. No matter how advanced a civilization becomes, distance remains important. Even a galaxy filled with intelligent life could still feel remarkably quiet because messages require so much time to travel. And yet, humanity continues listening. Since the 20th century, scientists have searched for signals from other civilizations. Radio telescopes scan the sky looking for unusual transmissions. Researchers analyze enormous amounts of data. The effort is often referred to as SETI, the search for extraterrestrial intelligence. The idea is straightforward. Radio waves travel efficiently through space. A technologically advanced civilization might use them for communication. If so, traces of those signals could potentially be detected across interstellar distances. Over the years, many intriguing observations have been reported. Some signals briefly captured attention before eventually receiving natural explanations. Others remain unexplained but inconclusive. So far, none have provided convincing evidence of extraterrestrial intelligence. The silence continues. But the search itself reveals something important. Humanity is no longer simply wondering whether life exists elsewhere. We are actively looking. The question has moved from philosophy into science. And as technology improves, our ability to search grows stronger. Future observatories may detect signals too faint for current instruments. Advanced telescopes may identify technological signatures around distant stars. Some scientists even propose searching for evidence of massive engineering projects constructed by highly advanced civilizations. Ideas that once belonged entirely to science fiction are now being discussed in scientific literature. The universe remains mysterious. But it is becoming less mysterious with each passing year. Still, communication is only part of the challenge. Even if humanity detected a nearby civilization tomorrow, another problem would immediately arise. Reaching them. Because while messages travel at the speed of light, physical objects move much more slowly. And that brings us back to Voyager. The tiny spacecraft continues drifting through interstellar space, carrying humanity's message outward. It is a reminder of both our achievements and our limitations. We have built machines capable of leaving the heliosphere. We have sent ambassadors into the galaxy. Yet compared to the distances involved, our progress remains small. Voyager has been traveling since the 1970s. And still, the nearest stars remain unimaginably far away. Which raises a fascinating question. If Voyager keeps moving for thousands, millions, and even billions of years, what will ultimately happen to it? Will it encounter another star? Will it collide with something? Or will it wander through the Milky Way forever? The answer reveals just how empty the galaxy truly is. The answer reveals just how empty the galaxy truly is. When people imagine space, they often picture a crowded environment. Movies show spacecraft weaving between planets, asteroids, and stars. Science fiction worlds are filled with traffic, stations, and constant activity. The universe appears dense and busy. Reality is very different. In truth, space is overwhelmingly empty. The emptiness is so extreme that it becomes difficult to appreciate. Even within our own solar system, the planets are separated by enormous distances. Vast regions contain almost nothing at all. A spacecraft can travel for years without coming anywhere close to another object. Once you move beyond the planets, the emptiness becomes even more profound. The region between stars is not packed with obstacles. It is mostly void. There are particles drifting through interstellar space. There are clouds of gas and dust. There are magnetic fields and cosmic rays. But compared to the distances involved, these features are incredibly sparse. Imagine taking a single grain of sand and placing it inside a gigantic stadium. That comparison still understates how empty some regions of space can be. This has important consequences for Voyager. Many people wonder whether the spacecraft might eventually collide with something. An asteroid. A comet. A rogue planet. Perhaps even another spacecraft. While such events are theoretically possible, the odds are extraordinarily low. The galaxy contains countless objects, but it also contains unimaginable volumes of empty space. Voyager is far more likely to pass harmlessly through the darkness than strike anything significant. In fact, the spacecraft could continue traveling for millions of years without experiencing a major collision. That is how vast the Milky Way truly is. Consider the stars themselves. There are hundreds of billions of them within our galaxy. That sounds crowded. Yet because the galaxy is so enormous, the average distance between neighboring stars remains immense. If stars were represented by small marbles, many would be separated by kilometers of empty space. The galaxy is not a tightly packed city. It is more like an enormous wilderness. A wilderness stretching across 100,000 light-years. Within that wilderness, Voyager is incredibly small. Its golden antenna. Its instruments. Its famous golden record. All of it occupies only a tiny amount of space. Compared to the galaxy, the spacecraft is almost microscopic. This perspective makes Voyager's journey feel both inspiring and humbling. On one hand, it represents one of humanity's greatest achievements. A machine built by a young civilization that managed to leave its home system. On the other hand, it highlights how tiny we are compared to the larger universe. The Milky Way will hardly notice Voyager's presence. Stars will continue forming and dying. Nebulae will evolve. Galactic structures will shift. Meanwhile, the spacecraft will quietly continue along its path. And if enough time passes, truly extraordinary changes will occur. Thousands of years from now, the world will be unrecognizable. Languages will evolve. Technologies will change. Entire cultures may transform beyond recognition. Yet Voyager will still be traveling. Millions of years from now, even larger changes are possible. Species evolve. Continents move. Climates change. The galaxy itself continues its slow rotation. Voyager's journey unfolds on timescales that dwarf ordinary human experience. In many ways, it has become a messenger from a particular moment in history. A snapshot of Earth in the late 20th century. A relic carrying information about a civilization that existed during a brief chapter of cosmic time. And because the spacecraft may survive for so long, some scientists have considered an intriguing possibility. What if another civilization eventually discovers it? The probability is extremely small. But not zero. If an intelligent species encountered Voyager millions of years in the future, they would find something remarkable. Evidence that another technological civilization once existed. Evidence that somewhere in the galaxy, on a small planet orbiting an ordinary star, intelligent beings built machines and wondered about the universe. The golden record would still be there. The greetings. The music. The images. A message crossing the ages. Whether anyone ever receives that message remains unknown. But Voyager's existence demonstrates something important. Humanity did not simply look at the stars. Humanity reached toward them. And while Voyager continues its lonely journey, scientists are already dreaming about something even more ambitious. Not sending messages to the stars. Not sending robotic probes. But sending human beings themselves. A goal that may become one of the greatest challenges in the future history of our species. A goal that may become one of the greatest challenges in the future history of our species. For thousands of years, every major chapter of human history has involved exploration. Our ancestors crossed deserts, mountains, and oceans in search of new opportunities. They ventured into unknown territories despite danger, uncertainty, and enormous risks. Again and again, humanity pushed beyond familiar horizons. The stars may simply be the next horizon. But unlike every frontier that came before, this one is separated by distances so vast that they redefine the meaning of travel itself. Reaching another continent required months. Crossing an ocean eventually required weeks. Flying across the world now takes hours. But reaching another star may require decades, centuries, or even longer. The challenge is unlike anything our species has ever attempted. Yet scientists continue studying possible solutions. One of the most exciting projects proposed in recent years is known as Breakthrough Starshot. The concept is surprisingly simple in principle, though extraordinarily difficult in practice. Instead of launching a large spacecraft, researchers propose sending tiny probes attached to ultralight sails. Powerful lasers located near Earth would direct immense amounts of energy toward those sails, accelerating them to incredible speeds. If successful, such probes could travel at a significant fraction of the speed of light. At those velocities, the journey to Proxima Centauri might take only a few decades rather than tens of thousands of years. For the first time, reaching another star within a human lifetime begins to appear possible. The engineering challenges remain enormous. The technology does not yet exist in a fully operational form. But the idea demonstrates an important point. Humanity is no longer merely dreaming about interstellar exploration. We are beginning to design it. Of course, sending tiny robotic probes is very different from sending people. Human beings require food, water, air, protection from radiation, medical care, psychological stability. A spacecraft carrying a crew would be vastly more complex than any robotic mission. Radiation alone presents a major obstacle. Outside Earth's protective magnetic field, travelers are exposed to energetic particles capable of damaging cells and increasing health risks. Long journeys would require sophisticated shielding. Then there is the issue of time. Even if future spacecraft become dramatically faster than Voyager, interstellar voyages could still last decades. Imagine boarding a spacecraft knowing you may never return to Earth. Knowing that by the time you arrive, everyone you once knew may be gone. The emotional implications are profound. Explorers of the future may face challenges that are not only technological but deeply human. And yet, history suggests that some people will be willing to try. Curiosity is one of the defining traits of our species. It drove humans across oceans. It carried explorers to the poles. It sent astronauts to the moon. The same impulse may someday carry humanity to the stars. Perhaps future generations will establish settlements around distant suns. Perhaps entirely new civilizations will emerge beyond the solar system. Perhaps humanity's descendants will one day view interstellar travel the way we view international flights today. Right now, such possibilities seem distant. But many achievements once seemed impossible before they became reality. What matters is that the first steps have already begun. Every telescope searching for exoplanets. Every spacecraft exploring the solar system. Every scientific breakthrough expanding our understanding of physics. All contribute to a larger journey. A journey that may eventually lead beyond the sun. And while humanity dreams about the future, Voyager continues its own voyage through interstellar space. Far behind it, Earth circles the sun. Far ahead lies the vastness of the Milky Way. The spacecraft moves silently through darkness, carrying a message from a civilization that dared to imagine what might exist beyond its home world. A civilization still asking questions. Still exploring. Still looking outward. Because the deeper we study the universe, the more we realize something remarkable. The cosmos is not only larger than we expected. It may be stranger than we ever imagined. The cosmos is not only larger than we expected. It may be stranger than we ever imagined. One of the greatest surprises in modern astronomy is how often the universe refuses to behave the way scientists expect. Again and again, observations have revealed realities far more unusual than theory predicted. Before Voyager explored the outer planets, many researchers imagined cold, relatively inactive worlds. Instead, they found volcanoes erupting on Io. Possible oceans hidden beneath Europa's ice. Violent storms raging across Neptune. Active geology in places once considered frozen and lifeless. The lesson was clear. The universe enjoys surprising us. And the farther we look, the stranger things become. Take rogue planets, for example. For generations, people assumed planets always orbited stars. That seemed obvious. After all, every planet in our solar system circles the Sun. Yet astronomers now believe countless planets may wander through the galaxy entirely alone. These are known as rogue planets. Worlds without suns. Worlds drifting through interstellar darkness. Some may have been ejected from their original systems during violent gravitational interactions. Others may have formed independently under unusual conditions. Whatever their origins, they challenge traditional ideas about planetary systems. Imagine standing on a planet where there is no sunrise. No sunset. No bright star dominating the sky. Only darkness stretching in every direction. Such worlds may exist by the billions. Then there are neutron stars. The remnants of massive stars that exploded long ago. These objects compress enormous amounts of matter into astonishingly small volumes. A teaspoon of neutron star material would weigh billions of tons on Earth. The laws of physics still apply there. But they operate under conditions almost impossible to reproduce anywhere else. And beyond neutron stars lie black holes. Few discoveries have captured the public imagination more powerfully. Black holes are regions where gravity becomes so intense that not even light can escape. For decades they existed only as theoretical predictions. Today, astronomers have observed compelling evidence of their existence throughout the universe. Some are only a few times more massive than the Sun. Others contain millions or even billions of solar masses. At the centers of many galaxies, including the Milky Way, enormous black holes lurk. Invisible. Powerful. And still not fully understood. The more scientists study them, the more fascinating they become. Some black holes generate jets of energy stretching across vast distances. Others consume surrounding material with extraordinary efficiency. These objects remind us that the universe contains environments far beyond ordinary human experience. And yet perhaps the most mysterious discoveries involve things we cannot see directly at all. Consider dark matter. Astronomers have observed that galaxies rotate in ways that cannot be explained by visible material alone. There appears to be additional mass present. Mass that exerts gravitational influence but does not emit or reflect detectable light. This invisible component is called dark matter. Scientists estimate that it may account for far more matter than everything we can actually observe. Stars. Planets. Nebulae. Galaxies. All the familiar objects in the universe may represent only a small fraction of what truly exists. And the mystery deepens further. Observations suggest that the expansion of the universe is accelerating. Something appears to be pushing galaxies apart at increasing rates. Researchers refer to this phenomenon as dark energy. Together, dark matter and dark energy may constitute most of the universe. Yet their true nature remains unknown. Think about that for a moment. Humanity has explored the Moon. Sent probes beyond the heliosphere. Observed galaxies billions of light-years away. And still, most of the universe appears to consist of things we do not fully understand. The cosmos remains filled with unanswered questions. Questions about matter. Questions about energy. Questions about the origin and ultimate fate of everything. Voyager's journey reminds us of this reality. The spacecraft did not solve every mystery. Instead, it revealed how many mysteries remain. Each discovery opened the door to new questions. Each answer led to deeper uncertainty. That is the nature of exploration. The frontier never truly ends. And perhaps that is what makes the universe so compelling. No matter how far we travel, no matter how much we learn, there is always something beyond the horizon waiting to be discovered. Something larger. Something stranger. Something entirely unexpected. And among all the questions still facing humanity, one may be the most important of all. How did this vast universe begin in the first place? How did this vast universe begin in the first place? It is one of the oldest questions humanity has ever asked. Long before telescopes existed, people looked at the stars and wondered where everything came from. Different civilizations developed their own stories. Some imagined cosmic beings creating the heavens. Others described worlds emerging from chaos, darkness, or primordial oceans. For thousands of years, these explanations remained the best answers available. Then science entered the picture. As observations improved, astronomers gradually realized something remarkable. The universe was changing. It was not static. It was not eternal in the way many people once believed. Instead, it was evolving. One of the most important discoveries came from studying distant galaxies. When astronomers examined their light, they noticed something unusual. Most galaxies appeared to be moving away from us. Not just a few. Almost all of them. The farther away a galaxy was located, the faster it seemed to be receding. At first, this result seemed strange. Why would galaxies be flying apart? The answer emerged through a powerful realization. Space itself was expanding. To understand this idea, imagine drawing dots on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. No single dot occupies the center of the expansion. The space between them simply grows. The universe behaves in a similar way. Galaxies are not necessarily racing through space like cars on a highway. Instead, the fabric of space itself is stretching. Once scientists understood this, an extraordinary conclusion followed. If the universe is expanding today, then it must have been smaller in the past. And if we continue tracing that expansion backward through time, we eventually reach a state where everything was compressed into an incredibly hot and dense condition. This idea became known as the Big Bang theory. Contrary to popular descriptions, the Big Bang was not an explosion occurring inside empty space. It was the rapid expansion of space itself. The beginning of the observable universe as we know it. Approximately 13.8 billion years ago. The temperatures were unimaginable. Matter existed in forms completely unlike anything around us today. There were no stars. No planets. No galaxies. Only an intensely hot sea of energy and particles. As the universe expanded, it cooled. Gradually, simple particles combined. Then atoms formed. Millions of years passed. Gravity slowly gathered material together. The first stars ignited. The first galaxies emerged. Cosmic structures began taking shape. Everything we see today ultimately traces its origins back to that ancient beginning. In a very real sense, every atom within your body has a cosmic history. The hydrogen in water originated shortly after the Big Bang. The carbon in your cells was forged inside stars. The oxygen you breathe was created through stellar processes billions of years ago. Human beings are not separate from the universe. We are products of it. The atoms making up our bodies were assembled through events stretching back across cosmic time. This realization is one of the most profound discoveries in science. When Voyager carries a message from Earth into interstellar space, it is not merely transporting information. It is carrying material that shares a common origin with the stars themselves. The spacecraft, the planets, the sun, humanity. Everything belongs to the same cosmic story. Yet despite the success of the Big Bang theory, many mysteries remain. What happened before the Big Bang? Did time itself begin at that moment? Are there other universes beyond our own? Could our universe be only one part of a much larger reality? Scientists continue searching for answers. Some theories propose entire collections of universes. Others suggest that space and time behave in ways we do not yet fully understand. The deeper researchers investigate, the more complex the picture becomes. What once seemed like a simple question has evolved into one of the greatest scientific challenges ever faced. And while humanity studies the origins of the cosmos, another equally fascinating question remains. What will happen in the distant future? Because just as the universe had a beginning, it also has a future. A future stretching trillions upon trillions of years beyond the present day. A future so vast that even Voyager's incredible journey becomes only a tiny moment within it. Part 22. A future so vast that even Voyager's incredible journey becomes only a tiny moment within it. When we think about the future, we usually imagine years. Maybe decades. Sometimes centuries. Rarely do we think in terms of millions or billions of years. The universe, however, operates on entirely different timescales. Compared to cosmic history, human civilization is almost unimaginably young. Recorded history covers only a few thousand years. Agriculture appeared roughly 10,000 years ago. Modern technology emerged within the last few centuries. These periods feel significant to us. But on a cosmic clock, they are barely noticeable. To understand the future awaiting the universe, we must first understand that nothing lasts forever. Not planets. Not stars. Not galaxies. Everything changes. Everything evolves. Even the sun. At the moment, our star appears stable. Every second it converts enormous amounts of hydrogen into helium through nuclear fusion. This process generates the energy that warms Earth and supports life. But the sun's fuel supply is not infinite. One day, billions of years from now, the hydrogen in its core will begin running low. When that happens, dramatic changes will occur. The sun will expand. Its outer layers will grow larger and larger. Eventually, it will become a red giant. A colossal star many times larger than it is today. The inner planets will face catastrophic consequences. Mercury will almost certainly disappear. Venus will likely share the same fate. The future of Earth remains uncertain, but conditions on our planet will become extremely hostile long before the sun reaches its maximum size. Oceans may evaporate. Temperatures will rise. Life as we know it will no longer be possible. This transformation will not happen tomorrow. Nor next year. It lies billions of years in the future. Yet it serves as a reminder that even stars have lifespans. Nothing remains unchanged forever. After the red giant phase, the sun will shed much of its outer material into space. What remains will become a white dwarf. A small, dense stellar remnant slowly cooling over immense periods of time. The brilliant star that once illuminated the solar system will fade. Its age of dominance will come to an end. But the universe itself will continue. Other stars will still shine. Other planetary systems will still exist. Galaxies will continue their slow evolution. In fact, one of the most dramatic future events involving our galaxy has already begun. The Milky Way and the Andromeda Galaxy are moving toward one another. At first, this seems alarming. After all, galaxies contain hundreds of billions of stars. A collision sounds catastrophic. Yet space is incredibly empty. When the two galaxies eventually merge billions of years from now, most stars will pass one another without direct collisions. Instead, gravity will gradually reshape both systems. Their structures will distort. Their forms will change. Eventually they will combine into a single larger galaxy. The night sky of the distant future would look spectacular during this process. Massive streams of stars would stretch across space. New regions of star formation would emerge. The entire appearance of the heavens would transform. And through it all, time would continue moving forward. Billions of years. Then trillions. As the universe ages, star formation will gradually slow. The raw material needed to create new stars will become increasingly scarce. One by one, stellar nurseries will grow quieter. The cosmos will begin changing in ways almost impossible for humans to witness directly. The era of bright young stars will not last forever. And eventually, the universe may enter a period unlike anything we see today. A future dominated by ancient remnants. White dwarfs. Neutron stars. Black holes. The long twilight of cosmic history. It is a future so remote that Voyager itself will be ancient beyond comprehension. The spacecraft may survive for millions of years. Perhaps even longer. But compared to the lifespan of the universe, even millions of years represent only the beginning. The true future of the cosmos stretches far beyond anything humanity has ever experienced. And what happens in those unimaginably distant eras remains one of the most fascinating questions in all of science. Because the ultimate fate of the universe is still not fully understood. Because the ultimate fate of the universe is still not fully understood. Scientists have spent decades trying to answer one of the biggest questions imaginable. How does everything end? Not the end of a civilization. Not the end of a planet. Not even the end of a galaxy. The end of the universe itself. At first, this may sound impossible to predict. After all, the universe is unimaginably large and extraordinarily complex. Yet by studying its expansion, astronomers have developed several possible scenarios for its distant future. The most widely accepted possibility today is known as the heat death of the universe. Despite its dramatic name, it is not a sudden catastrophe. It is a slow process unfolding over unimaginable spans of time. To understand it, we must return to a discovery mentioned earlier. The universe is expanding. Not only is it expanding, but observations indicate that the expansion is accelerating. Galaxies are gradually moving farther apart. Over billions and trillions of years, this separation becomes increasingly significant. Imagine a universe growing larger and larger while stars continue consuming their fuel. Eventually, the supply of material needed to create new stars diminishes. Existing stars begin to die. One by one, the bright lights of the cosmos fade. The youngest stars disappear first. Then older populations follow. Galaxies that once blazed with activity become quieter. Darker. Older. As trillions of years pass, fewer and fewer stars remain. The universe slowly loses its sources of light. The great stellar age comes to an end. What remains are the remnants. White dwarfs. Neutron stars. Black holes. Cold planetary bodies drifting through darkness. At this stage, the universe would appear dramatically different from the one we know today. The night skies of any surviving observers would be almost empty. Many distant galaxies would have moved beyond visibility due to cosmic expansion. The observable universe would shrink. Not because galaxies disappeared, but because they became too distant for their light to ever reach one another. Civilizations living in that era might have no evidence that countless other galaxies once existed. Their view of reality could be far more limited than ours. And still, time would continue. Trillions upon trillions of years would pass. Eventually, even the stellar remnants would change. White dwarfs would cool. Neutron stars would evolve. Black holes would dominate the cosmic landscape. For an incredibly long period, black holes might become the most significant structures in existence. Yet even they are not eternal. One of the most surprising predictions in physics comes from the work of Stephen Hawking. According to modern theory, black holes slowly lose energy through a process now called Hawking radiation. The effect is incredibly weak. For large black holes, the timescales involved are almost impossible to comprehend. But given enough time, even the largest black holes may eventually evaporate. The process could require numbers of years so large that writing them out becomes impractical. Yet in principle, it may happen. If so, the universe would enter an even darker era. An era where most familiar structures have vanished. An era of immense emptiness. A cosmos approaching maximum entropy. This scenario is often considered the most likely future based on current observations. But it is not the only possibility. Some theories suggest alternative endings. Others propose that unknown physics may alter the universe's fate. Dark energy remains mysterious. Its true nature is not fully understood. Future discoveries could dramatically change current predictions. The universe has surprised scientists before. It may do so again. What makes these possibilities fascinating is not simply their scale. It is the perspective they provide. Human beings often focus on immediate concerns. Days. Months. Years. Yet the universe operates across spans of time so vast that entire civilizations become brief moments. Voyager's mission feels long to us because it has lasted decades. Compared to cosmic history, however, those decades are almost invisible. And still, the spacecraft continues its journey. A tiny machine crossing interstellar space while the universe itself follows a path measured in billions and trillions of years. In many ways, Voyager serves as a reminder of humanity's place within this larger story. We are small. Yet we are capable of understanding remarkable things. We can study stars. We can explore planets. We can investigate the history and future of the cosmos. And perhaps most importantly, we can ask questions. Questions that connect a small world orbiting an ordinary star to the vast universe beyond. Questions that ultimately lead to one final realization. The story of Voyager is not really about a spacecraft. It is about us. The story of Voyager is not really about a spacecraft. It is about us. At first glance, Voyager appears to be little more than a machine. A collection of electronics, antennas, instruments, and metal components launched into space decades ago. But if we look deeper, Voyager becomes something else entirely. It becomes a reflection of humanity itself. Every bolt, every circuit, every scientific instrument aboard the spacecraft exists because generations of people chose to ask questions. Questions about the planets. Questions about the stars. Questions about what lies beyond the horizon. Curiosity built Voyager. Curiosity launched it. And curiosity continues to guide its journey today. Throughout history, human beings have always been drawn toward the unknown. Ancient explorers crossed oceans without knowing what awaited them. Early astronomers mapped the sky using only their eyes. Scientists spent centuries trying to understand the laws governing nature. Again and again, humanity expanded the boundaries of knowledge. Voyager represents one of the most ambitious examples of that tradition. The spacecraft was never guaranteed to succeed. Many things could have gone wrong. A launch failure. A technical malfunction. A damaged instrument. Any number of problems might have ended the mission early. Yet Voyager survived. Not because it was lucky, but because thousands of people dedicated years of effort to making it possible. Engineers designed systems capable of operating under extreme conditions. Scientists developed instruments to study unfamiliar worlds. Mission teams monitored the spacecraft across enormous distances. The success of Voyager was a collective achievement. A reminder of what people can accomplish when they work toward a common goal. And the discoveries that followed changed humanity's understanding of the solar system forever. Before Voyager, many of the outer planets were mysterious points of light. Today we know them as complex worlds. We have seen active volcanoes on distant moons. Gigantic storms on giant planets. Icy landscapes hiding potential oceans. Each discovery expanded our understanding of what is possible. Perhaps even more importantly, Voyager changed the way we see ourselves. When the spacecraft looked back toward Earth, it provided a perspective unlike any previous image. Our planet did not appear large or powerful. It appeared tiny. A small world suspended in a vast darkness. Every human being who has ever lived. Every civilization. Every achievement. Every conflict. Every dream. All of it occurred on that tiny world. The realization can be humbling. But it can also be inspiring. Because despite our small size, humanity has accomplished extraordinary things. A species that evolved on a rocky planet managed to understand the motions of planets, decode the physics of stars, and send machines beyond the edge of the heliosphere. That achievement is remarkable. It demonstrates that intelligence can overcome enormous obstacles. It demonstrates that curiosity has value. And it demonstrates that exploration matters. Voyager's journey is far from over. The spacecraft continues moving through interstellar space even now. Its power is gradually decreasing. One day, its instruments will fall silent. Its transmissions will cease. Mission Control will receive its final signal. And after that, Voyager will continue alone. No longer communicating with Earth. No longer sending scientific data. Simply drifting through the galaxy. Yet even when that day arrives, its mission will not truly be over. The spacecraft will remain a symbol. A symbol of a civilization that looked toward the stars and decided to explore. A symbol of a species that refused to remain confined to its home world. A symbol of humanity's endless desire to learn. Long after its electronics stop functioning, Voyager will continue carrying the golden record. A message from Earth. A message from us. A message moving through the darkness between the stars. And perhaps that is the most remarkable part of the entire story. Not that Voyager traveled so far. Not that it crossed into interstellar space. But that humanity was willing to try. Because every great journey begins with a simple decision. The decision to go beyond what is known. And that decision may ultimately define our future among the stars. The final chapter of Voyager's story is not about where the spacecraft is going. It is about what its journey reveals about the human species itself. The final chapter of Voyager's story is not about where the spacecraft is going. It is about what its journey reveals about the human species itself. Nearly 50 years ago, a rocket rose into the sky carrying a machine unlike any that had come before it. At the time, nobody could know exactly how the story would unfold. The mission was ambitious. The technology was limited. The distances were enormous. Yet humanity launched Voyager anyway. And that decision changed history. Over the decades, the spacecraft traveled farther than any human-made object ever had. It revealed new worlds. It transformed planetary science. It expanded our understanding of the solar system. And eventually, it crossed into interstellar space. But perhaps Voyager's greatest achievement was something less tangible. It changed perspective. Before Voyager, the outer planets were distant mysteries. Before Voyager, interstellar space was an abstract concept. Before Voyager, much of the solar system remained unexplored territory. Today, those places feel more familiar. Not because they are close. Not because they are easy to reach. But because Voyager showed us what was there. Knowledge replaced uncertainty. Discovery replaced speculation. The unknown became known. That process lies at the heart of human progress. Every major leap in history began with curiosity. Someone asked a question. Someone challenged an assumption. Someone looked beyond the horizon and wondered what existed on the other side. Voyager is part of that tradition. It represents humanity at its best. Not divided by borders. Not focused on conflict. But united by exploration. United by the desire to understand reality. The spacecraft carries no weapons. It claims no territory. It seeks no resources. Its purpose is knowledge. Its purpose is discovery. Its purpose is to learn. And in many ways, that makes Voyager one of the most extraordinary objects ever created. Right now, as these words are being spoken, Voyager continues moving through interstellar space. The distance between the spacecraft and Earth grows larger every second. Radio signals take many hours to cross the gap. The sun shines faintly behind it. The planets are far away. The familiar world that created it has become a tiny memory in the darkness. Yet Voyager continues. Silently. Patiently. Relentlessly. Its journey reminds us that exploration is never truly finished. Every answer creates new questions. Every discovery reveals new mysteries. Every frontier leads to another. The universe is larger than we once believed. Older than we once imagined. Stranger than we once expected. And despite everything we have learned, we have explored only a tiny fraction of it. The nearest star remains unimaginably distant. The galaxy contains hundreds of billions of suns. Beyond the galaxy lie countless others stretching across the observable universe. The scale is overwhelming. Yet humanity continues looking outward. That determination may ultimately become our greatest strength. Because one day, future generations may build spacecraft far beyond anything we can currently imagine. One day, humans may travel to other stars. One day, settlements may exist around distant suns. One day, the dreams that seem impossible today may become ordinary reality. If that future arrives, Voyager will be remembered as one of the first steps. A small beginning. A pioneering mission that ventured into the darkness long before humanity was ready to follow. And perhaps millions of years from now, long after our current civilization has become history, Voyager will still be drifting among the stars. A silent witness to a moment when a young species on a small blue planet decided to reach beyond its world. A message in a bottle cast into a cosmic ocean. A reminder that curiosity can carry us farther than we ever imagined. Thank you for joining me on this journey through space, time, and the incredible story of Voyager. If you enjoyed the video and want to explore more mysteries of the universe, don't forget to subscribe and support the channel. There are many more stories waiting among the stars. Until next time, keep looking up. Because the universe is still waiting to be discovered.